So we are in a brand new unit, unit number 6. So in this unit, we will still be using some concepts of graphing. So you still need to know how to plot points, how to do the slope, all that good stuff. But we will also be algebraically solving problems by graphing and algebraically. So let's start with a definition of systems of equations. So a system of linear equations is 2 or more equations containing 2 or more variables. So now we're going to be solving equations simultaneously. We're going to be solving equations simultaneously. So there's more than one variable that we'll be working with. So if you have a solution for a system, that means you have an ordered pair that satisfies all the equations. If you have a solution for a system, means those answers work for each equation. So for instance, the example that I highlighted. There are 3 examples up here. As long as you write one of them, then that's fine. That way you have an example of what one looks like. So you have y equals -5 over 2x plus 2, and 3y minus 4x equals -40. So that's a system. 4 comma -8 is a solution. So 4 comma -8 means that the answer is x equal to 4 and y equals -8. So if you plug those numbers into each of those 2 equations, you will get both sides to match up. Same thing for the second example. X equals -2, y would be -1. Same thing for this third example. You have 3 equations. You also have 3 variables. So that means x equals -2, y equals 6, z equals -3. Fairly similar to what one of your extra credit questions was on Friday. So a system is 2 equations that you're going to solve at once. The solution is the ordered pair that it goes with it. Any questions by anybody so far? Any questions by anybody? All right, then let's keep it moving. Scroll up just a little bit so I can keep everything, that part of the screen so far. So, if an ordered pair is a solution, then it will make all equations true. So that means, if I give you a problem, and I tell you that this ordered pair is an answer, then that means every equation that I'm given, it has to work. It has to work for whatever you're given. If it fails at any point, then it fails for the whole problem. So it's an all or nothing type deal. It's an all or nothing type deal. So we're going to look at 2 examples. You're going to see an example where it works, and you're going to see an example in which it doesn't. So let's look at example 1. They're asking, is -4 comma -5 a solution for 4x plus 5y equals -41, 3y minus 5x equals 5. So they want to know, will this point work for that problem? Will x equals -4 and y equals -5 work for that problem? So the easiest way to figure it out is to plug each number in and see if both sides match. If both sides are equal. So both sides have to be equal in order for the answer to be yes. So let's start with the first equation. And this is similar to what you'll be doing in the IXL that is due on Wednesday. 4x plus 5y equals -41. So they're telling you that x is -4 and y is -5. So you take those numbers and you plug them in. So that's 4 times -4 plus 5 times -5. So if this works, we have to get an answer of -41. If it doesn't, then the problem failed. So let's do some work. What's 4 times -4? So that's -16. And what's 5 times -5? -25, thank you, no. So now we have to subtract them. -16 minus 25 gives you -41. So those match. So far we're good. So far we're good. Since the first one worked, now you go check the second. If the first one works, you check the second. If the first one fails, the problem is over. If the first one fails, don't bother checking the second. It either all works or it all doesn't. One or the other. So since the first equation works, now we do the second equation. So y is -5. So 3 times -5 minus 5 times -4. Same rules apply. So we need to get an answer of 5. 3 times -5 is what? Then -5 times -4 gives you what? Try that again. I like the 20. So remember, if you have a negative times a negative, what's that? Negative is positive. -15 plus 20 is 5. Which means those match. So your answer is yes. So your answer is yes. Any questions, example 1? So remember, if the first one works, you check the second one. If the first one fails, the answer is no. First one works, check the second one. First one fails, stop the problem, the answer is no. So let's do a second example. 1 comma negative 6, a solution for 6x minus 4y equals 30, and 12x plus 3y equals 6. So they want to know, is x equals 1 and y equals negative 6 a solution for that problem? So we're going to do exactly what we just did. So the first equation goes first. X is equal to 1, so 6 times 1 minus 4 times negative 6. And we have to get an answer of 30. So let's work it out. 6 times 1 is 6. Negative 4 times negative 6 is what? Let's see, positive 24, thank you. Then 6 plus 24 is 30. So we have two sides that match. First equation's good. First equation's good. If the first equation is good, then we go to the second. If the first equation failed, the problem is over. So now we do the second equation. So 12 times 1 plus 3 times negative 6, and we have to get an answer of 6. What's 12 times 1? Well, that should be simple. Anything times 1 is itself. Positive 3 times negative 6. Negative 18. So it seems right now that the only two people that are in the class right now is Shemaiah and Noah. So I can give them extra credit, right? What's 12 minus 18? So negative 6. So you have a negative 6, you have a positive 6. Those match? No. They don't match, so your answer is no. It failed. No, it failed. The first one worked, the second one didn't. Sorry, that fails. Questions on example 2? All right, not seeing any, not hearing any, so we're going to move on. So this is the baseline for a system. If I give you the answer, you should be able to tell me, is it that true or false? If I give you an ordered pair, you should be able to tell me, does this work or does it not work? But you're not going to get the answer all the time or ever. You're going to have to solve for it. So now we're going to start solving for it. The first way to solve for it is by graphing. So, just so you know, there are 3 ways to solve a system. Graphing, we've done a lot of graphing. substitution, and elimination. Substitution and elimination are algebraic methods. Those use algebra. Graphing uses graphing. So we're going to first start with graphing. So when you are graphing, there are three ways that that the final answer will present itself. There are three ways the final answer will present itself, and it uses this little diagram that's right here. So, the first type of answer is that there is exactly one solution. What does it mean to have one solution? You have two lines that intersect. Two lines that intersect. So in your notes, you need to put the name, put what it is, little sketch, so that you know what it looks like, and put what it means. So two lines intersect, that means they're going to meet at a point. Whatever that point is, that's your answer. So that's one type of solution. Another type of solution is called infinitely many solutions. Infinitely many solutions means that the lines would coincide. Coinciding lines mean you have two of the same line. You have two of the same line. It looks like you have one line on the graph, but it was literally two lines on top of each other. And then the third type is called no solution. No solution means you're going to have two parallel lines. You have two parallel lines. And if two lines are parallel, that means they will never intersect. They will never touch each other. The lines will never touch each other. So those are the three types that you would see when we're graphing. All right, now let me give you a few moments, those people who need to finish drawing them, to draw them. Obviously, if you printed it, you don't need to wait for me to draw it before we do example number one. So again, when we graph, we use all those same rules and concepts for graphing. Plotting points, using the slope, vertical and horizontal lines. So if you still struggle with graphing, it is on you to come in and get the extra help. Remember, you're a freshman getting ready to move on into sophomore year. Sophomore year is geometry. Geometry, you graph. So you're still going to be using the same things. So let's graph. So we are given two equations. We're going to graph them and see what the solution is. So first step is to rewrite the equation into slope-intercept form if necessary. So that means put it as y equals mx plus b. If we need to. In this case, we don't need to. The next step is to graph each equation. So you graph it like it's its own separate problem. So y equals 3. So remember, if you have y equals just a number, that is a horizontal line. Those are just horizontal lines. Go to the y-axis. Go to where 3 would be. And you draw a horizontal line. So that's y equals. X equals a number is a vertical line. It's a vertical line. Go to the x-axis. Go to where -5 is. And draw a vertical line. Any questions on the two lines? They don't necessarily have to look like those. Those are examples of what it could look like. They're still intersecting. That means you're going to have one answer. So now we have to identify what it is. So the blue line and the red line, they intersected right there. So that means we now need to tell what that point is. We have to identify what is that point. So they met up there. So for the x value, that's 1, 2, 3, 4, -5. The y value, 1, 2, 3. X equals -5, and y equals +3. And that is your final answer. Any questions, example 1? Trust and believe, ladies and gentlemen. Those of you who struggle with graphing, you're going to get exposed, especially with graphing. When we get to substitution and elimination, if you can't solve an equation, you're going to get exposed. So if it's exactly one solution, that means you have to tell me what it is. So if the lines intersect, that means you're only going to have one answer, but you do have to tell what it is. So you don't write exactly one solution. You write what was the point where they cross. They meet, you tell where they are, where it met. So we got time to get one more in, then we'll do the rest on Wednesday. So Sinai, this will probably look a little similar to that example that you saw at the top. But remember, the main thing is it doesn't have to look exactly like that picture. They just need to meet in order for it to be one solution. So we have y equals -4x plus 8, and y equals 2/3 x minus 6. So this is where that y equals mx plus b slope intercept form is back. So for the first equation, what's the slope? fraction. What's the y-intercept? Y-intercept is 8. So go to the y-axis, put your first point at 8. And then since your slope is negative 4 over 1, you're going to go down 4 to the right 1. So for these equations, for these lines, I strongly suggest you go all the way down. You go as far as you can go. Because you want to see where they meet. Let's do the second equation. Second equation, what's the slope? Two-thirds. Thank you, Noah. Slope is 2/3. What's the y-intercept? -6. Remember, make sure y'all take the sign that's sitting in front of it. So go to the y-axis. 1, 2, 3, 4, 5, 6. So your slope is 2/3. So go up 2 to the right 3. Now, if you notice, you have a point that was laying right on top of each other. You have a point that laid right on top of each other. So that means you're going to have exactly one solution. You just have to tell what is it going to be. So now we have to identify that point. So that's 1. Not a very good drawing. 1, 2, 3. So 3 for x. 1, 2, 3, 4. -4 for y. 3, -4. You need to check that graph because that means something you did is wrong. That should land exactly at 3, -4. Most of the equations you all going to get are going to land exactly. Now, those of you that don't have graph paper, that might be an issue. So